Guys, I'm back for the second review video. So the second thing you need to know is how to solve systems of equations. And I'm really sorry, mine got a little messed up on this line. Yours is probably not like this. When we are solving systems of equations, we have a lot of options. We already talked about elimination and substitution in Unit 1, and now we're talking about matrix operations, which actually I'm going to go ahead and switch that to row operations. That's where you are making it into a matrix, and then you're going to add or subtract rows to get the entry in row 2, column 1 to equal 0. So this is just saying that there's going to be a 0 in the bottom left, basically. Okay, here's how that works. And this first one is going to be a decimal, so I'm going to pick it. Actually, you know what? I'm going to wait just a second. I'm going to go ahead and talk about Cramer's rule, inverses, and then the 3x3s. So for Cramer's rule, that's where, like, let's say we're trying to find x. It would be negative, and we're going to put a determinant on top and a determinant on bottom. And the top one is going to be the matrix without column 1, the x's. And then the bottom part is going to be the matrix without column 3, which is the constants, or the numbers, the ones that don't go with an x or a y. And then matrix inverses is when you want to set it up like this, where you have a matrix with your x's and your y's, okay, with the numbers in front of them, and then you have your matrix that you want to find, and it equals numbers over here. So instead of setting it up like one big matrix, you put the variable coefficients over here and the numbers over here, and then you multiply by the inverse, because dividing by matrices isn't possible. And there will be a question on your test that asks you what we use inverses for. We use inverses because we can't divide, so instead of dividing, our alternative is to multiply by the inverse. Okay, and then we have the fourth one, which is by hand. If it's a 3x3, this is where you want to eliminate y or z, and then plug it back in and solve for the others. So I can't really give you a great explanation of this one because it really just makes more sense to see the problem. This is probably the one thing that is actually, you see why you're doing it. You've got to eliminate y or z, so you only have one variable left, and then you plug that answer back in. I will say this though, when I get to 3.3 or 3x3s in the next page, the ones on the test will be exactly like the ones on the review. These were very different depending on what type of equations you got. The ones on the test are exactly like the ones on the review, okay? And then you can also use a calculator to type them in. If you want to do that, you're going to go to second matrix. You're going to go over to edit. And then the next thing you're going to do is go to second matrix, RREF. And then you're going to go back to second matrix, and I know you guys are probably out of space here, and pick A. Okay, so just practice typing that into a calculator so that you know how. There will be a no calculator portion and a calculator portion on this test. All right, let's talk about how to actually do some of these. So for row operations, and by the way, if you feel like you're okay and you want to go ahead and try them on your own, pause the video here. If you want to see them, keep watching. So first I'm going to change this into a matrix, where you just take the numbers out front. Keep in mind that you should have a column for your x's, a column for your y's, and a column for your constants. Okay, and that's the order they're going to go in each time. Then we want to get the row 2, column 1 to be 0. So I'm going to multiply by something so that when I add 6 to whatever's right here, I get 0. So I want this to be -6, basically is what I'm saying. And I can make that happen by multiplying by -3. But I have to multiply to -3 all the way across. And then I'm going to add these two rows together. 6 minus 6 is 0. 5 minus 21 is -16. And 6 plus 48 is 54. And then basically what you have now is the equation -16y equals 54. Because again, these were x's, so there's 0 x's. These were y's, so there's -16y. And this was my equal sign, this is my constant, 54. So then I need to do 54 divided by -16, which is -3.375. So we're just going to call that -3.4. And then you take that answer and you plug it back in for y. So I'm going to plug it back in for y right here. So it'll be 2x plus 3.4 times 7 is 23.8 equals -16. And then I'm going to do 2 steps on my calculator at the same time. I need to subtract this 23.8 to the other side. So -16 minus 23.8 is -39.8, and I'm actually not going to write that down just yet. I'm going to divide that by 2 because there's a 2 in front of the x. X equals -19.9. Okay, I know this one ends up being a decimal, and that's okay. But there's your 2 parts of the answer. You need an x and a y. Okay, and that one's row operations. For Cramer's rule, this is where you want to do the determinants. You start with x, and you're going to put a negative with the one on top. It doesn't actually matter which part you put the negative on, but you need a negative. So then on top, you're going to put the matrix without column 1, which is the x's. So not these. So 6, 11, 5, 4. And then on the bottom, you're going to put the matrix without column 3, or basically skip over the constants. So that's covering up these. 7, 6, 11, 5. And then you're going to find both determinants. I'm not going to over-explain determinants because they're on the front side, but at the top it'll be 24 minus 55. You're going to keep the negative out there, and then 24 minus 55 is -31. So on top, I end up with positive 31. So I have 2 negatives sitting out here, so that becomes positive. Then on the bottom, I have 7 times 5, which is 35, minus 11 times 6, which is 66. Look at that, negative 31. And 31 divided by negative 31 is negative 1. So we get x equals negative 1. And then you just take that x and you plug it back in to find y. So when I plug it in next to the 7, 7 times negative 1 is negative 7. And I'm going to add that 7 to the other side. So I get 6y equals 18. Divide by 6, y equals 3. And that's Cramer's rule. Then we have matrix inverses. This is where you set up a matrix with just the coefficients. And then the next one will be your x and your y, and it equals the constants. And what we want to do essentially is divide by this to get rid of it, because it's being multiplied by the one we want by itself. Since we can't divide, we multiply by the inverse of the matrix on the left. And the inverse is 1 over the determinant. The determinant of this matrix is 14 minus 15, which is negative 1. And then when you fill in the matrix, you flip the first diagonal. So the 7 and the 2 have to switch spots. And then the 5 and the 3, the second diagonal, become negative. Or if they're already negative, they would become positive. And then we have to multiply this by this one. Okay, and I'm going to do a little bit of side work over on the left as I multiply this row times this column, because that's how you multiply matrices. So I get 7 times negative 1, that's negative 7. Negative 3 times negative 5, that's 15. And I add those two answers together because they're within the same column. Okay, so that's going to be 8. And then I have negative 5 times negative 1 is 5. And 2 times negative 5 is negative 10. Well, 5 minus 10 is negative 5. Okay, and then I still have this 1 divided by negative 1, which is negative 1, that I need to multiply by. So basically, it just changes my answers to negative 8 and positive 5. But sometimes that's a number. Like if it was a 1/2, I would need to multiply both of those by 1/2. Okay, and then this is going to be your x value, and this is going to be your y value. Just make sure you know which one's which.